Okay, so now we're going to solve question 7 from GATE CSE 2023. The question states that consider the two functions. They are giving us the two functions over here. This part I have written, don't look at it right now. I will come to that. Now they are giving us that t is from 0 till infinity. They are giving us these two statements, right? 1 and 2. Which one of the following options is true? They are in the options, they are basically suggesting the different permutations for these two statements to be true. The first statement is correct, the second statement is correct, both of them are correct, none of them are correct, right? So basically this is how the whole question is. So we have to basically consider both of these and see if they are true or not. See, over in the first one, they are giving us that for some t. Most people will not read this part for some, and they're directly going to see at this expression and say that for t greater than 0, g of t must be greater than f of t. If they do like that, then it is going to cause problems, right? It is always said that the devil lies in the details, and sometimes these small statements, reading them out, when you have basically distilled out the question that you have to consider only two statements and the validity of them only matters, then you can take out the time to read them every word, because that way, at least in technical domain, you will not make mistakes, right? So that is why read those one or two statements very clearly, right? For some t greater than 0, g of t is greater than f of t, right? To understand these, let's first draw them, right? So before drawing it, with these coefficients present, the simplified form of these equations would be this thing, right? Remove the coefficients and just consider them like that, right? If you were to draw this out, then what would that be? It's 11th-12th concept, very simple concept. I could have drawn it with my own hands and then expressed to you, yes, this is the way it would be drawn, and then explain that to you. But why do that when you have a computer, right? So I will use the computer to draw both of these graphs and then explain to you how they are actually working, right? So this is the graph of your y is equals to t square. Here x is present because it is a software, so you have to take the software's parameters as the base case, right? So this is y is equals to t square, this is y is equals to t, right, replaced by x, right? And what is the graph? The graph is like this. This is the t square graph, and this is the straight line is the y is equals to t graph, right? And they are intersecting at what? They are intersecting at 1, 1, right? And look at this part. For certain region, the straight line is on top of, has more magnitude than your curved part, right? After that, the curved part picks up and the line is at the having lower magnitude, right? And then the whole thing expands like that, right? This is the basic kind of pattern which is present inside of without the coefficients. Now, even if you introduce the coefficients, the whole scheme of the graph would not change, right? The whole scheme of the graph would be approximately the same only, right? Just let me give you the exact graph that is being drawn, right? This has a coefficient of 0.01 and this has a coefficient of 4, right? So let's place that. So I place those coefficients over here, 0.01, x square and 4, right? With that those coefficients present and the same magnification being present, the graph looks something like this, right? The curved part expands a lot and the straight line has a more has a steeper slope, right? So right now, if you look at this, then you will say that look, now it is not the same pattern. Yes, it looks different. I agree with that. But the thing is, it looks different when the magnification is like that. If I were to increase the look at from a faraway point, then it is going to make a lot of sense. So I'm going to zoom out. Here is the functionality for zooming out, and look what happened. The curved part was below the straight part for a certain amount of time, then it became on top of the curve of the straight line, right? Then it became on top of the straight line, and then the curved part has a greater magnitude again. So same pattern again reflects itself, right? And why does it reflect itself? Man, as computer engineers, we have some exposure to why this happens this way, because your t square basically has a tendency to increase its magnitude much more strongly compared to t. So as you increase the quantity of t, this coefficient can be ignored and this quantity will be greater than this quantity, right? Hence this curved graph will always be greater than your straight graph after some point on the x-axis, right? That is a pattern that is going to be present, and at the very start of the graph, this is something that comes from the 11th 12th concept of derivatives. If you were to take the derivative of this t square, that is going to give you 2t, right? If you were to apply 0 to this, its slope becomes 0, right? This is the slope of this graph, right? Hence when this t square graph is drawn, it starts with 0 slope and then it increases, right? It starts with 0 slope and then it increases, while this thing, a constant, a t raised to power 1, when this is differentiated, it becomes nothing but a 1, right? It becomes 1. That means that your graph for this simple t is not going to have a slope that is not 0. Hence at starting it will increase at a faster rate, right? This is why at the starting, near the origin, your linear graph is always increasing having a greater magnitude than your parabolic graph, this curved graph, right? But as the values are increased and the whole behavior starts to converge, the curved graph is increasing, right? So it will intersect at some point, and that intersection happens, right? For y is equals to x square and y is equals to x, the intersection happens at what? The intersection happens at 1, 1, right? But for this thing, 0.01 and 4 being present as coefficients, the intersection is going to happen at what? It is going to happen at 400. I had to calculate it differently. You can very easily calculate it. This part I will leave to you as homework. This is the intersection point, right? That is going to happen. You can calculate it by equating this to this and then cutting out the x, right? Because one point of intersection is the origin, that is the x that you're cutting out, and the other part, this part, that x value you're going to get. Once you have the x value, then you directly apply 4 times that x value and you're going to get the answer, right? So that is the whole thing. Now I think that I've explained the whole thing in a very good manner. Now let's attack at the statements that were presented to us, right? The first statement says that at some t greater than 0, g of t is greater than f of t, right? So the linear graph is going to be greater than f of t for a short region at the starting, right? So this statement is true. As we have seen, this is greater than the curved part for this particular region, right? And the second one says that there exists a t such that for f of t greater than g of t for all small t greater than t, right? So basically it is claiming that your this function, f function, is going to be greater than your g function after some magnitude t some value of t is taken which is greater than some magnitude t. So basically it is saying that as we tend to infinity, as we increase the value of t, there would come a point after which your f of t is always going to be greater than t. Yeah, that is the behavior that we have observed. There is a point of intersection, and after that intersection, if you take anything else, then for that the curved graph is always going to have a greater magnitude than your straight graph, right? So that is also true. So this statement is also true. Both of these statements are true. Now which of the options gives this conclusion that both of them are true? Well, that is directly as visible over here. C, both 1 and 2 are correct, and that is the whole of this question's solution. It's a very simple question, but obviously it requires a bit of knowledge about graphs. That is what it requires. Yeah, very simple knowledge regarding graphs, right? Now you may say, how can I get all this knowledge, right? So you can basically, this is 11th 12th concept, graphing. There's a book by Aryanth regarding graphs. You can buy that, very simple book, tells a lot about it, or you can even search on YouTube regarding this. Somebody would have explained it, right? If nobody has explained it on the internet, comment it down in the video. I will make a separate video on it, right? Now with that, I would say have a good day. If you like the video, like and subscribe, and have a we see you in the next one.